Hi, today's reading this new book is called The Non-Resident Training Course, Navy Electricity Electronic Training Series, Module 8, Introduction to Amplifiers. Chapter 1, Amplifiers. Chapter 2, Video and Radio Frequency Amplifiers. Chapter 3, Special Amplifiers. Alright, throughout the text of this course, we'll be using the technical manuals associated with equipment we'll work on. You will find that below the notations at the end of some of the paragraphs. Notations would use to emphasize that safety hazards exist and care must be taken and are observed. Warning, operating procedure, practice, condition, etc., which may result in injury or death, not carefully observed or followed. Caution, and operating procedure, practice, condition, etc., which may result in damaged equipment, not carefully observed or followed. And note, in operating or practice or condition, etc., which is essential to emphasize. Chapter 1, Amplifiers. Learning objective. Learning objective is at the beginning of the end of the chapter. Learning objective is the preview information you are expected to learn. In this chapter, the comprehensive check questions are based on the objective basic success of completing the OCC, ECC. You indicated that you have mentioned the objective learning information. Learning objectives are listed below. Upon completion of this chapter, you will be able to define amplification, list several common uses, of two-way with the amplifiers are classified, list 4 classes of operations, 4 methods of the coupling, 4 impedance characters with 3 configuration transistor amplifiers, 3 define feedback, list 2 feedback, 2 types of feedback, describe and state 1 use of phase splitter, state common use for 1 advantage of push-pull amplifiers. Introduction. The chapter is a milestone with the show that the electronics previous bounds will have to concern more with the individual component circuits than electric complete circuits are subject to the chapter. For the other chapters, are mods for the concern with the circuit amplifiers, while components are discussed in discussion. Components of the explanation working with the components itself that have been previously covered in previous modules, but explanation of the component is really as it relates to the circuit. The circuits or chapters concern the circuit. This chapter concerns with amplifiers. Amplifiers are devices that provide amplification. This does not explain much, but it describes the amplifier. You know that what an amplification is, what it's used for. What is amplification? Just an amplifier is a device that provides amplification. Amplification is the process of providing increased amplitude. Amplitude is the term to describe the size of the signal. In terms of AC amplitude usually refers to the amount of voltage or current. 5-volt peak-to-peak AC signal would be larger than an amplitude of a 4-volt peak-to-peak AC signal. It is generally termed referred to as AC or DC interest of the in a circuit. The input signal, output signal could be large or small. AC or DC sine waves, non-sinusoidal or non-electrical, such as sound, light, and signals. Very general term, therefore very descriptive of itself, but it does sound much more technical than the word thing. It's not very impressive to refer to the input thing and the thing that comes out of the circuit. Alright, perhaps the concept of relationship with amplifier amplification amplitude will clear up if you consider the parallel situation analog and analogies. Magnifying glass is a magnifier that is such to provide with magnification group the magnitude side of an object. Relationship with the magnifier, magnification, magnitude, sum of the relationship amplifier, amplification, amplitude. The analogy is true with one of the other as well. Magnifier does not change the object being the magnified, is only the image that is larger, not objective itself. The amplifier output signal differs in amplitude with the input signal, but input signal still exists unchanged, so the object of the input signal, magnifier, amplifier control the image output signal. Amplifiers can be defined with a device enable the input signal with control an output signal. The output signal will have some or all the characteristics of the input signal, but will generally be larger than the input signal termed in voltage or current or power. Uses of amplification. Most of the electronic device amplifiers provide various amounts of simple amplification. Some of the most signals are originally too small or to control drive the desired devices. Some amplification is needed. For example, the audio signal given them of the record is too small to drive the speaker, so the amplification needed. The signal will be amplified several times between the needle of the record player and the speaker. Each time the signal is amplified, it is said to go through a stage of amplification. The audio amplifier should connect between the turntables and speaker system. Between Figure 1.1 contains several stages of amplification. A turntable, amplifier, speaker. Note the triangle used in Figure 1.1 to represent the amplifier with the triangle is a standard block of the diagram symbol for amplifier. Another example, the use of the amplifier shown in Figure 1.2. The radio receiver the signal picked up with the antenna is too weak, small to be used. The signal must be amplified before it is sent to the detector. The detector separates the audio signal from the frequency that was sent by the transmitter. The way this was done is discussed later in the training series. I got antenna to amplifier radio frequency. Detector separates audio from radio frequencies, and then amplifier audio frequency speaker. The audio signal from the detector will then be amplified to make it large enough to drive the speaker of the radio. Every electronic device contains at least one stage for the amplification. You will see the seeing of the amplifiers. Many devices for the work amplifiers will be either most of the Neets modules to follow this one. Alright, classification of amplifier. The most electronic devices use at least one amplifier, but there are many types of amplifiers. This is the module. Will not try to describe all the different types of amplifiers. It will be shown general principles of amplifiers, some typical amplifier circuits. Most amplifiers can be classified in two ways. The first classification is by their function. This means the basic voltage amplifier or power amplifier. Second classification is their frequency response. The other words what they are designed to amplify. If you describe the amplifier by these two classifications, function and frequency response, you will have a good working description of the amplifier. You may know what the exact circuitry is, but you will know the amplifier does and the frequency that is designed to handle. Voltage amplifiers and power amplifiers. All amplifiers current control the input signal with the amplifier, control for the current output with the amplifier with the connection with the amplifying device, electron tube, transistor, magnetic amplifier. Such a circuitry with the amplifier determines the classification. Amplifiers are classified in voltage, power, amplifier, voltage amplifiers, and amplifier which the output signal is larger than the input signal voltage. In other words, voltage amplifier applied with the voltage over the input signal. And power amplifier is the amplifier in which the output signal is greater than the input signal. In other words, the power amplifier is the power over the input signal. Most of the power amplifiers used as a final amplifier stage of amplification, control, or drive the output device. Output device could be a speaker, indication device, antenna, or heads-on tape recorder. Whether the device power to make it work or drive, it comes from the final stage of amplification, which is the power of the amplifier. Figure 1.3 shows the simple block diagram. The voltage amplifier input-output signal, the power amplifier input-output signal. Notice view A with the output signal voltage is lower than the input signal voltage. Since the current values of the input-output signals are shown, you cannot tell if there's a power gain in addition with the voltage gain. 200 millivolt peak-to-peak AC, and then through the amplifier output 4 volt peak-to-peak. Show the block diagram. Voltage, power amplifier input signal 10 volts peak to peak, 100 milliamperes or 1 watt of power. Going through the amplifier output voltage 5 peak to peak, 2 amperes, 10 watts of power. Alright, view B with the figure output signal voltage less than the input signal voltage as voltage of the amplifier circuit has gained less than 1. The out power, however, there is greater than the input power, therefore the circuit is a power amplifier. Classification amplifier voltage power amplifier is made with comparing the characteristic of the input output signal. If the output signal is larger than in the voltage amplitude, then the input signal amplifier voltage amplifier is no voltage gain, but output power is greater than the input power amplifier is the power amplifier. Frequency response amplifiers. In addition to being classified with the function, amplifiers classified by frequency response. The frequency response of an amplifier refers to the band of frequency range amplifiers were designed to amplify. You wonder the frequency response is important and what is the amplifier designed to apply the signal 1000 hertz should work just as well with the 1000 megahertz. The answer of the component of the amplifier responds differently with the different frequencies. The amplifying device, electron tube, transistor, magnetic amplifier, etc. You will have the frequency limitation respond the different way with the frequency chain capacitors, inductors, and the circuit can change with the reactance of the frequency chain and even slight amount of the capacitation inductance between the circuit wiring and other components of inter-electrode capacity self-inductance can become significant in high-frequency state. Since the response of the components, various frequency components of the amplifier selected to amplify the certain range of band of frequencies. Alright, note for explanation, inter-electrode capacitance and self-inductance, see Neets Module 2, Introduction Alternating Current Transformer, 6, Introduction to Electron Emission Tubes and Power Supplies, and 7, Introduction to Solid-State Device Power Supplies. 3 broad categories of frequency response. The amplifiers: audio amplifier, radio frequency amplifier, and video amplifier. An audio amplifier is designed to amplify frequency to 15 Hz to 20 kilohertz. The amplifier that is designed to entire band frequency and the band of the frequency contained in the audio range considered the audio amplifier. And the term RF amplifier, RF stands for radio frequency. The amplifier is designed to amplify the frequency of the 10 kilohertz to 100,000 megahertz. Simple amplifier will not apply with the entire radio frequency range, but an amplifier with a frequency band that includes the radio frequency range is considered a radio frequency amplifier. A video amplifier is designed to amplify the band of frequencies from 10 Hz to 6 MHz, but this is such a wide frequency that these amplifiers are called wideband amplifiers. With a video amplifier that amplify very wide band frequency does not have the gain of the narrow band amplifiers. It also requires a great many of the components of the narrow band amplifier to enable the ability of the wide range of the frequencies. Or transistor amplifiers. Transistor amplifier is a current control device for the current base for the transistor, which is independent of the emitter base by the control of the current in the collector of the vacuum tube amplifier, also for the current control device, grid bias control plate current. These facts expanded upon the Neets Module 6, Introduction Electronic Emission Tubes and Power Supply, Module 7, Introduction Solid State Device and Power Supplies. You might hear the vacuum tube is a voltage-operated device since the grid does not need to be drawn current. Well, the transistor, the current operated, they must be agreed with the statement. Both of the vacuum tube and the transistor are still control devices. The whole secret of understanding the amplifier, to remember that fact, current control is the name of the game, and once the current is controlled, you can either give it a voltage gain or power gain. The chapter will use the transistor amplifiers to present concept principles of the amplifiers. These concepts apply with the vacuum tube amplifiers, in most cases magnetic amplifiers, as well with the transistor amplifiers. If you wish to study vacuum tube equivalent circuit with the transistor circuit presented in the equivalent excellent source is the EIMB Navy C 0967 LP 0000120 electronic circuits. First amplifier concept is discussed in class of operation of amplifiers. Amplifier class operation. Class of amplifiers determine the amount of time in relationship with the input signal, the current flow for the output signal, the function for the operating point of the amplifying device, the output operating point of the amplifying device is determined based by the bias supplied with the device. The four classes of operation with the amplifier are A, B, and B, and C. Each for the operation have certain use of the characteristics, not one of the class operation better than the other. Then the selection no one class is better than the other. The selection best class operation determined by the use of the amplifying circuit. The best class of operation phonograph is not the best class of the radio transmitter. Alright, Class A, a simple transistor amplifier operated with the Class A as shown figure 1-4. The signal, since the output signal is 100% or 360 degrees, copy of the input signal is the output circuit with the flow of the 100% input signal time. The definition of the Class A amplifier current flows at 100% of the input signal. Alright, voltage collection current, resistor 1 output signal, your transistor, the input sine wave, resistor 2, solid voltage, ground. The Class A amplifier is a character for the good fidelity, low efficiency fidelity, meaning the output signal just like the input signal, all respect except for the amplitude. It has the same shape of the frequency. In some cases, there may be phase difference between the input and output signal, usually 100 degrees, but the signals are still considered with a good copy. The output signal is not like the input signal free shape of the frequency signal, with it said to be distorted, or distortion is the undesired shape of the signal with the input and output. The efficiency amplifier refers to the amount of the power delivered over the output carried with the power supplied to the circuit. The sense that every device takes power operated with the amplifier operates 360 degrees. Input signal is more than if it only operates 180 degrees. That input signal, the amplifier uses the power more power, less power available. For output signal efficiency is lower. The some classes of A operates have current flow with a 360 degrees input signal. They are low efficiency acceptable Class A amplifiers because they are used the efficiency not important, but as fidelity. Alright, Class A amplifying device for the base bias for such a way with the current flow for the device at 51% of the 99% of the input signal amplifier operated with the Class AB with the simple Class AB amplifier is shown figure 1-5. Your AB classifier has the grounded transistor, resistor 1 output signal, input signal between resistor 2, your voltage current capacity. Note the output signal distort. The output signal no longer has the same shape of the input signal. The portion of output signal that has to be cut off is called with the lack of the current through the transistor. The emitter probably becomes positive, but the transistor cannot conduct the cover the base. The emitter junction is no longer forward biased. The further increase of the input signal will cause the increase of the output signal voltage. Class AB amplifiers have better efficiency port fidelity with the Class A amplifiers. They are usually when output signals need to be not to be complete reproduction of the input signal, but both positive and negative portion of the input signal must be available at the output. Class A and B amplifiers usually define amplifiers operating with the Class A and B, and because the Class A operates only 100% of the input signal, Class B amplifiers discussed and operate on a 50% input signal amplifier operating between the two limits and is an operating Class AB. Class B operation, as was stated with the Class B operation amplifier, operates at 50% of the input signal. Simple Class B amplifier shown in Figure 1.6. Got voltage CC, BB, EE, resistor 1, resistor 2, on tangent, and the sim wave, and then turn in and out. In the circuit shown in Figure 1.6, the base emitter will not allow the transistor to count whenever the input signal becomes positive. Therefore, the negative portion of the input signal will reduce the output signal. We may wonder what the Class B amplifier would be instead of the simple rectifier. If only one half the input signal is desired output, the answer is that the rectifier does not amplify output signal. The rectifier cannot be higher than the amplitude of the input signal. Thus, Class B amplifier will not only produce the half-put input signal, but amplifies it as well. Class B amplifiers are twice as efficient as the Class A amplifiers, since the amplifying device only conducts the use of the power half of the input signal. Class B amplifiers are used the case is exactly a 50% input signal must be amplified. If less than 50% of the input signal is needed, the Class C amplifier is used. Alright, Class C operation. Figure 1.7 shows the simple Class C amplifier. Note that also small portion input signal present with output signal, since the transistor does not conduct except during a small portion of the input signal. The most efficient amplifier is also have the worst fidelity. Output signal bears little resemblance to the input signal. Figure 1.7 shows the simple Class C amplifier, resistor, transistor, resistor 1, resistor 2, output wave, input wave. Class C amplifiers are used for the output signal needed only present during the part of the one half of the input signal. Amplifier operates less than 50% of the input signal is operating in Class C. Amplifier coupling. Early is the model with which state that almost every electronic device contains at least one state of the amplification. Most devices contain several stages of the amplification. Therefore, several amplifier stage amplification added the single stage would provide with the required amount of the amplification. For example, a single-state amplification would provide with a gain of 100. The desired gain of the device is 1,000. The two-stage amplification will be required. A two-stage might have gains of 100, 10, 100, 20 to 50, 25 to 40. Overall gain is product of the individual stages. 10 times 100 equals 20 times 50, 20 times 5 times 40 is 1,000. They all equal 1,000. Figure 1 show that 1.8 show the effect of the adding the stage of the amplification stage. The amplifications are added in single increase. The final output from the speakers increase. Turntable amplifier speaker, turntable amplifier, amplifier speaker, turntable amplifier, amplifier speaker. Whether the amplifier is one series of the device of the single stage that connected with the two or other devices, the top view of the figure 1.8, there must be some of the way to signal to enter leave the amplifier. This process of transforming energy between the circuits is known as coupling. These various ways of the coupling signals in and out of the amplifier circuit. The following description: some of the more common method of amplifier coupling. Direct coupling. The method of coupling used with the least number of the circuit elements is perhaps easiest to understand with the direct coupling. Direct coupling output. One stage is connected directly to the input of the following stage. Figure 1.9 shows the two direct coupled transistor amplifiers. Alright, 1.9 shows the direct coupled transistor amplifiers. You have resistors, one on the voltage input going to the transistor, and then the 7 volts goes to the transistor 2, but stops on real resistors 5, 6, and then past the 3 and 6, and so you have 610 volts and 615 volts. Note the output over the collector transistor Q1 is connected directly to the input base of the transistor Q2. The network of the resistor 4, 5, and 6 with the voltage divider used to provide with the bias the operating voltage of the Q1 and Q2 transistor. Entire circuit provided the two-stage amplification. Direct coupling provided the good frequency response sensitive to no frequency sensitive components. Inductors and capacitors are used. Frequency response of the circuit. Even the direct coupling is affected only by the amplifying device itself. The direct coupling has several disadvantages. However, the major problem is the power supply requirement. The direct coupled amplifier. Each succeeding stage requires a higher voltage load of the voltage divider resistors, large amount of the power biasing and come before very complicated addition, difficult to match impedance from stage to stage with direct coupling. Impedance matching is covered a little later in this chapter. Direct coupled amplifier is not very efficient. Loss of the increase of the number of the stages, increase because of the disadvantage. Direct coupling is not used very often. Resistor capacitor coupling. The most commonly used the coupling of the amplifier resistor capacitor coupling. The RC coupling network is shown in Figure 110. Show 110 RC coupled transistor input. The transistor 1 grounded. The capacitor 1-2 is in a short with resistor 1 and 2 and in between the transistor Q1 and transistor 2 output grounded. Your network of the resistor 1, resistor 2, capacitor 1, enclosed with the dashed line figure with the coupling network. You notice that the circuitry of the transistor 1 and transistor 2 is incomplete. The additional so that you can concentrate with the coupling network. The resistor 1 acts with the load resistor with the Q1 transistor. The first stage, the develop the output signal of the stage 2. You remember the capacitor react with the AC, DC with the capacitor. C1 block with the DC with the transistor Q1 collectors, but with the pass with the AC output with the resistor 2. Develop the pass and couple the signal input with the signal and the Q2 transistor. With the second stage of the arrangement allowed the coupling signal will isolate the biasing at each of the state that solves many of the problems associated with the direct coupling. The RC coupling does have a few disadvantages of the resistor. You use the DC power so the amplifier how low is the efficiency of the capacitor tends to limits the low frequency response of the amplifier amplifying device and its limits to the high frequency response. For audio amplifiers, usually not a problem. The techniques to overcome the frequency limitations will be covered later in this model. Before you move on to the next coupling, consider the capacitor of the RC coupling. You can probably remember the capacitive reactance is determined by the following. Capacitive reactance is 1 over 2 times the frequency times the capacitation. Explain the low frequency limited with the capacitor frequency of the capacitive reactance increase the cause more signal to be lost for the capacitor. The formula for the capacitive reactance also shows the value of the capacitance. Capacitive value of the capacitance should be the relatively high, so the capacitive reactance can be kept as low as possible. So for the capacitor, for the coupling element, the capacitive should be relatively high, so that it will couple the entire signal well, not reduce and distort the signal. Your impedance coupling. Impedance coupling is very simple to RC coupling. The difference is use for the impedance device as a coil to replace the load resistor of the first stage. Figure 111 to show the impedance of the coupling network between the two-stage amplification of the inductor 1 from the load with the Q1 transistor valve of the output signal first stage. Since DC resistance of the coil is low, the efficiency of the amplifier stage is increased. The amount of the signal developed in the output stage depends on the inductive reactance and the L1 inductor. Remember the formula inductive reactance is 2 times the frequency times the load. Figure 111 impedance for the coupled transistor in its own circuitry. You see in the capacitor the inductor 1 and resistor 1 from in between the grounded transistor 1 input and transistor 2 output. The formula shows the inductive reactance larger, either inductive frequency or both must be high, but therefore the load inductor should be relatively large amount of the inductors are most effective with the high frequency explained with the impedance for the coupling not used for audio amplifiers. The rest of the coupling network, capacitor and resistor function are just as part of the capacitor 1 resistor 2 and resistor coupling network. Coupling 1 is the signal between the stage between the DC and the resistor 1 develop the input signal of the second stage. Transformer coupling. The figure 112 shows the transformer coupling network between two-stage amplification. The transformer acts as T1 coupling, T1 winding coupled with the signal for the first stage. For the second stage, the figure 112, the primary T1 winding acts load with the first stage of the transistor 1. Secondary, the transistor 1 acts to develop the impedance for the second stage, the transistor 2. The no capacitors needed to become the transformer action, a couple of the signal between primary and secondary first transformer 1 winding. Figure 112 shows the transformer coupled to transferred amplifier, the input of from the transformer Q1 to its own circuitry, transformer 1 winding, voltage also collected capacitance collected current, grounded with going into the transistor 2 for output and grounding. Inductors that make up the primary and secondary transformer, the very little to see the efficiency of the amplifier very high. The transformer coupling very often use the final output between the first final amplifier stage output device to cover the impedance match qualities in for the transformer. The frequency response with the transformer coupled amplifier is limited, but the inductive response with the transformer just limited impedance coupling. Impedance consideration for the amplifiers. As mentioned, the efficiency of the impedance for the amplifier, the reason for this may not be peculiar. You should have known the amplifier current control device. Know that there are 2 other principles you should try to keep in mind. First, there's no such thing something for nothing. In electrical means every time that you do something is a signal to cause something. It must mean a loss of fidelity to get a higher power to get a higher power. For some other compromises must also be made. The circuit design, regardless of the compromise, every stage will require use of power that brings up with the second principle possible to do things in as efficiency as possible. The improvement in design electronic circuit is an attempt to do things cheaply with the possible in terms of power when all the other requirements of the fidelity, power, output, frequency, range, etc. have been met. Brings us to efficiency. The efficiency device is the one that does the job of the least loss of the power, the largest loss of power that could cover the impedance difference between the output within one circuit with the input with the next circuit. Perhaps the way to think of the impedance difference mismatch between the circuits is to think of the different size water pipe. And if I try to collect 1 inch of the water pipe to a 2-inch water pipe with one of the out ends after, you would lose water. You must use an adapter. Impedance matching devices like an adapter. Also, in connection with the two devices, different impedance will allow loss of power. Figure 113 shows the two circuits connected together. The circuit number 1 conserve the AC source of the voltage series, which output impedance represented with the resistor 1 that can be conserved with the AC source of the output signal of the AC voltage that comes from the circuit number 1 through the output of the impedance. The impedance in the circuit number 2 is represented by a resistor interior. The source of the resistance is shown variable to show that what will happen to input and impedance of the circuit number 2 change. Circuit number 1 and circuit number 2. Circuit number 1 output impedance 1 kilo ohm. The voltage fuse 10 volts resistor 1 and resistor 2 on contact circuit. And then a chart figuring of impedance matching the coupling 2 circuits. So you have resistor 2, amplifier voltage and resistor 2, power and resistor 1, power and resistor 2. The chart of the circuit shows the effect of the change of the input and impedance of the circuit number of the 2, the resistor 2, and current in the amplifier, single voltage developed input of the circuit number of the AE voltage for the resistor 2, for the power of the output of the circuit number of the power resistor 1, and power input of the circuit number of the power resistor 2. Two important factors that brought with this chart of the first power of the input of the circuit number 2, the greatest of the impedance are equal to match. Power is also equal to the output of the circuit, the number of the input of the circuit number 2, the impedance are math. The second fact is that the largest value voltage signal is developed at the input circuit number 2, which the input impedance is much of the larger output is independent of the circuit number. However, the power of the input circuit number 2 is very low under these conditions. So much of the decide when the condition you want to coupling 2 circuits together to select the components appropriate. Two important points for the remember about the impedance matching with this valve. The maximum power of the transfer requires the match impedance to take the maximum voltage impedance for the circuit that requires an intentional impedance mismatch for the circuit that provides with the input signal. Alright, impedance character for the amplifier configuration. Now that you have seen the importance of impedance matching the stage of the electronic device, that you wonder what the impedance character of the amplifier has. Input and output impedance transfer. Resistor amplifiers depend on the configuration of the transistor. Module 7, the introduction solid state device and power supplies. You were introduced to 3 transistor configurations: common emitter, common base, common collector. And examples of these configurations depend on the characteristics shown in Figure 114. Common emitter with the common base and common collector. Not only approximate impedance values are shown, but this is because the exact impedance values vary with the circuit to circuit. They depend in particular with the circuit. It depends on the device of the transistor. Other circuit components, the value and impedance can be computed by dividing the signal voltage by the signal current. Therefore, input signal impedance is equal to input signal voltage over input signal current, or output signal impedance is equal to output signal voltage over output signal current. Your common emitter with the configuration provides the medium input and impedance of the medium output impedance. The common base configuration provides a low input impedance, high output impedance. The common collector provides a high input impedance, the low output impedance. The common collector configuration is often provided with the impedance matching between high output impedance and low input impedance. Amplifier stage of the transformers coupled with the turn ratio of the transformers could be selected and provided the impedance matching with the Neets module 2 introduction alternating current transformer. You were shown the relationship between the turns ratio and impedance ratio in a transformer. The relationship is expressed in the following as number of terms in the primary over the number of terms in the secondary is equal to the square root of the impedance of the primary and over the impedance of the secondary. As you can see, the impedance matches between the stages accomplished with the combination amplifier configuration complete once you've the amplifier circuit. Amplifier feedback. Perhaps you have ever been around a public address system when equal and the high-pitched noise will come from the speaker. Someone will turn down the volume of the noise, will stop the noise, and an indication of the amplifier. At least one state of the amplification has begun oscillation. Oscillation is covered by the detailed Neets Model 9 introduction wave generation wave shape circuit. For now, you need to know the realization oscillation with a small part of the signal amplifier output being sent back to the input amplifier. Single amplifier, but again sent back to the input whether they amplified again. The process continues to result with the loud loud noise out of the speaker. Process sends part of the output signal of the amplifier back into the input amplifier. It's called the feedback. The two types of the feedback amplifiers, the positive feedback, also called the regenerative feedback, or negative feedback, also called degenerative feedback. The difference between the two types is whether the feedback signal is phase out of the input signal. Positive feedback occurs with the feedback signal in phase with the input signal. Figure 115 shows the block diagram. Amplifier positive feedback. Note if the feedback signal is in phase with the input signal, this means the feedback signal will add regeneration into the input signal. Thus, the result of the larger amplitude output signal that would occur without feedback. This type of the feedback is with the causes the public address system the squeal and described above. You have the input signal going into the amplifier feedback, but connected to the network feedback signal going back to the input output signal. Figure 116, a block diagram, amplifier, negative feedback. In this case, the feedback of the signal is out of phase with the input signal, means the feedback signal will be subtracted from the degeneration input signal. This results in lower amplitude output signal that would occur without its feedback. Input signal going from the amplifier feedback network output signals larger. Sometimes the feedback is not desired to occur with the amplifier. Half of the high frequency limits of the high frequency response of the amplifier. Unwanted frequencies occur with the result of some of the circuit component of the bias coupling network. Useful solution: unwanted feedback of the feedback network with the opposite type. For example, the positive feedback network will counteract unwanted negative feedback. Feedback is also used to get an ideal input with the normal maximum output signal desired for the amplifier. The amount of the output signal of the amplifier depends on the amount of the input signal. However, the input signal is too large, amplifying device will be saturated or cut off during the part of the input signal that cover the output signal to be distorted to reduce the fidelity of the amplifier. Amplifiers must provide the proper balance of the gain fidelity. 117 shows the way with which feedback can be used to provide maximum output signal without loss of the fidelity. View A with the amplifier, good fidelity, but less than gains, and then it could have been adding some of the positive feedback of view B with the gain with the state with the increase. The view C, the amplifier has so much gain, so large input signal, the output signal is distorted. The distortion is caused by amplifying device being saturated, cut off by adding negative feedback. As in the view D, the gain stage is decreased and fidelity of the output signal is improved. Figure 1H of the feedback used in an amplifier. Feedback used in amplifiers, positive network feedback. Feedback used in amplifier. Feedback used in negative feedback network. Or your positive and negative feedback are accomplished in many ways depending on the regional requirement of the feedback. The few effects of the method of the coupling feedback are present next. Positive feedback. As you have seen, the positive feedback is accomplished adding part of the output signal in the phase and input signal. The common base transistor amplifier is fairly simple to provide positive feedback. Some input and output signals are in phase. You need only to couple the part of the output signals back to the input. This is shown in figure 118. Feedback network is an amplifier made up of the resistor 2 and capacitor 2. The value of the capacitor 2 should be larger than the capacitive reactance, but it will be lower with the capacitor will couple the signal easily. This will give the input and output coupling capacitors C1 and C3. Resistor value of the resistor 2 should be the large limited amount of the feedback signal to ensure the majority of the output signal goes on to the next stage through capacitor 3. Alright, so you have your input from the capacitor 1 going around in the circuit, a closed circuit with signal going in transistor 1, transistor 3 with the voltage grounded, and the capacitor 2 and 3, capacitor 2 and 3, and then to resistor 3 and capacitor 3 voltage current collector grounded output. Alright, more common configuration. The transistor amplifier common emitter configuration. Positive feedback with a little more different with its configuration because the input-output signals are 100 degrees out of phase. Positive feedback can be accomplished by feeding portion of the output signal over the second stage back into the input first stage. The arrangement is shown in figure 119. 119 shows the positive feedback in 2 stages transistor amplification. Show the input capacitor 1, voltage B, voltage CC, both resistors 1 and 4 going to capacitor, resistor 2 and 3 and 4 and 5 and 6, feedback network. Alright, this figure shows that each of the stage of the amplification has 880 degrees phase shift. That means the output signal of the transistor 2 with the phase of the input signal transistor 1 portion of the output signal of transistor 2 is coupled back into the transistor 1 through the feedback network. The capacitor 3 and resistor 3 should have the largest resistance, limited amount of the signal feedback. The network capacitor should have the largest capacity of the capacitive reactance flow, and capacitor will couple the signal easily. Sometimes the positive feedback you eliminate the effect of the negative feedback caused by the circuit components. Only one way of which the circuit components can be called as negative feedback is shown in the figure 120. In view A, the common emitter transistor amplifier shown with the emitter resistor 2 has been placed in the circuit provided with the proper biasing, temperature, stability, undesired effect of the resistor developing the signal at an emitter phase in the input signal of the base. The signal is called the changing of the current of the emitter resistor. The current through the transistor changes. You might think the signal emitter with the form of the positive feedback since the is in phase with the input signal, both emitter signal with the negative feedback with the current through the transistor and is controlled by the base emitter with the bias. Both the base and the emitter both become positive more being the same amount, but at the same time current will not increase. If it is the difference between the base and emitter voltage with the current and control of the current flow of the transistor. To eliminate the negative feedback of the emitter resistor, some of the way must be found with the remove of the signal from the emitter. The signal can be coupled to ground with the decoupled emitter of the transistor unwanted would be unaffected. Exactly what was done. The decoupling capacitor C3 in view B with the place of the emitter with the transistor 1 ground crosses the emitter resistor. The capacitor should have the high capacitance at which path of the signal with the ground easily. The decoupling capacitor C3 should have the same quality as the coupling capacitors C1 and C2. When the circuit of the coupling capacitors are coupled called bypass capacitors. Figure 120A show the decoupling bypass capacitor and transistor amplifier capacitor 1 going to resistor 1 on a shortage of voltage supply to resistor 2 on second voltage supply to resistor 3 in a phase transistor 2. Alright, 120 for the decoupling bypass capacitor transistor amplifier. Input signal, sine wave going from the capacitor into resistor 1 into following the voltage. The resistor 2 grounding with the transistor and a capacitor 2 in its own circuitry. The voltage from VB and the resistor voltage resistor of the resistor 3 to capacitor 2 in between the resistor 1 and the resistor 2 and capacitor C3 signal output. Regardless of the method, you provide positive feedback with the circuit. The purpose is to increase the output signal amplitude. Negative feedback is accomplished with the adding point with the output signal out of phase. The input signal that you see with the emitter resistor, common emitter transistor amplifier develop the negative feedback signal. Other methods of providing negative feedback are similar to those methods that you provide positive feedback. The phase relation with the feedback signal input signal only difference. The figure 120 show with the negative feedback for the common emitter transistor amplifier. The feedback, the network of the capacitor 2, the resistor 2 coupled apart with the output signal transistor 1 back of the input. Since the output signal is 180 degrees out of phase, the input signal is coupled with the negative feedback. 122, the negative feedback of the transistor amplifier. Capacitor input circuit with the resistor voltage and VB and VC on the outside of the resistor running on a circuit of resistor 1, resistor 2, resistor 3, feedback circuit. In between resistor 1, 2, and 3 is the transistor Q1 and the capacitor 3 output. Negative feedback is used to improve fidelity amplifier, limiting the input signal with the negative feedback can be used also to increase the frequency response amplifier. The game of the amplifier to greatly limit the frequency response reach. When negative feedback is used with the feedback signal, decrease the output signal to decrease the limits of the frequency response with the amplifier. Smaller feedback signal move means of the effect of the game within the feedback. This will improve the frequency response of the amplifier. Audio amplifiers. An audio amplifier is described the amplifier with a frequency response of 15 Hz to 20 kHz. The frequency response amplifier can be shown graphically with a frequency response curve. The figure 122 ideal frequency response curve of the audio amplifier. The curve is practically flat. Figure from 15 Hz to 20 kHz. This means the gain amplifier is equal to 15 Hz and 20 kHz. Above 20 kHz and below 15 kHz, the gain is decreased. It drops off quite rapidly. The frequency response of the amplifier determines the components of the circuit. Figure 122 shows the ideal frequency response curve of the audio amplifier between 15 and 10 kiloohms. The difference between the audio amplifier and other amplifiers frequency response of the amplifier. Next chapter module will be shown. Technique components used to change the extent of the frequency response of the amplifier. The transistor itself will respond quite well to the audio frequency range. No special components are needed to extend. They modify the frequency response. You already have been shown the purpose of all the components for the transistor audio amplifier. The schematic diagram serves several auto amplifiers will be shown with the function. Each of the components will be discussed. Single-state audio amplifier. First single audio amplifier shown in Figure 123. Circle with the A with the common emitter. The RC couple the transistor audio. C1 coupler capacitor. The couples with the input signal of the transistor 1. Resistor 1 is developed. The input signal provide the bias for the transistor 1. Resistor 2. UV the emitter provide the temperature of the stability with the capacitor. On transistor 1. Capacitor 2 that provide the decoupling positive feedback signal that will be developed. The resistor 2. Resistor 3 collector load with the transistor 1 develop the output signal with the capacitor 3 with the coupling circuit. Capacitor couple the output signal with the next stage. The VC represented the collector supply voltage. Since the transistor common emitter configuration is provided the voltage amplification input with the output signal 180 degrees out of phase. The input and output impedance are both medium. And I accidentally pushed the mute button, so I'm going to check the tape.